Welcome! Do you know what the Medici family, Google search and the city of Königsberg have in common? No? Well, I'll tell you more about it in this video and the next one. In this video, we're going to describe what is social network analysis, how you can characterize and create a network, and how you can use it. In the next video, we will focus on the application for the humanities. Social network analysis relies on a mathematical theory that is called graph theory. In 1753, the famous mathematician Leonhard Euler formulated the problem of the 7 bridges of Königsberg. The city had 7 bridges on the Pregel River, across different neighborhoods and even 2 islands. So Euler was asking, can we devise a walk through the city, through all the areas of the city, that would cross each of those bridges once and only once? To answer this question, Euler represented the city and the river as a graph. Every area is represented by a node, and every bridge by a link or an edge. In this way, he realized that such a path does not exist. You can look up the mathematical explanation online. And this is how we get to graph theory. Graph theory offers all the tools to study relation between objects, which means to study networks. And the nice thing is, whatever kind of objects and whatever kind of relations. Now, try to imagine how many realities can be represented as a network. The networks of Facebook friendships, a family tree, linguistic relations, contacts during a pandemic, the World Wide Web. Do you see maybe now Google and the Medicis coming? But first, let's make a little bit of order. A network is constituted by a list of nodes, A, B, C, and D, and a list of edges, AB, BD, and CA, meaning the edge from A to B, etc., etc. Nodes can be all of the same type, for instance people, or maybe of multiple types, for instance people and books, if you want to represent a network of contributor to books. Networks with one kind of nodes are called unimodal networks, while those with different kind of nodes are called multimodal. You can characterize also the nodes, indicate for instance the name of a person, the age of a person, the title of a book, whatever you want. Links can also be of different types. They can have a direction, for instance. If we represent an epistolary network, there is a sender and there is a receiver, meaning if I send a letter to you, it's not the same as if you send a letter to me. And if we switch the node around, it's not the same relationship. Other relationships are undirected or symmetrical. For instance, being friends on Facebook, or maybe being siblings, or collaborating on a work. So networks can be directed or undirected, or even mixed, based on the kinds of edges that they contain. Edges can also have weight, that describe the strength of the relationship between 2 nodes. For instance, if I send 7 letters to you, we will have a stronger relationship than if I send only 1. Now, we have already seen how to represent networks as a set of nodes and edges. Now, let's turn to the mathematical representation of networks, matrices. Maybe I'm reminding you of your favorite class in high school, or maybe you have never seen what a matrix is. A matrix is formed of rows and columns. Each row, in our case, is a node, and each column is a node as well. At the intersection, you'll find a number representing the weight of the connection. If there is no connection, if there is no link, you will find a 0. Thanks to this representation, we can measure all kinds of things on our network. You can visualize the nodes with a lot of contacts, or the most influential nodes in a network, for instance, those that have not only a lot of contacts, but whose contacts are also very well embedded in the network. You can identify the nodes acting as brokers across disconnected groups, and you can even group the nodes in community with frequent contacts in the inside. You can look up more information on centrality measures, like degree between a centrality's eigenvector centrality online. So when graph theory, meaning all this mathematical processing, is applied to networks that represent social contacts, we call it social network analysis. And now maybe, before the next video, you go online and Google what is betweenness centrality. Well, now you're using graph theory again. In fact, Google uses the PageRank algorithm to rank web pages in their search engine, among other techniques. Basically, the World Wide Web is seen as a network of nodes, pages, and edges, hyperlinks between pages. The assumption is that if a page is linked by many other pages, it is more likely that that page is important. And the more important are the pages that link to a page, the more important that page is likely to be. In this way, it is possible to rank the uncountable pages that might be relevant for a certain query. To sum up, in this video we've introduced what is graph theory, and we have showed how you can represent a network and introduce the metrics that you can use to characterize the network. In the next video, we're going to see how you can apply all of this to the humanities.